I wanted to make a fairly simple video about felling wedges. It starts out covering just some of the basics that will probably only be of interest to those who are not familiar with felling wedges. It then gets into a few of the issues and some of the solutions to those problems. And unfortunately, coming out with the solutions ended up taking a lot more time than I wanted, so I'll apologize in advance for the length of this video. Felling wedges come in a significant variety. All of them are plastic. Plastic is the preferred material because if you use a steel wedge and you accidentally contact that with your saw, you're going to pretty much destroy a bunch of teeth in a hurry. Whereas with the plastic wedges, you can easily cut those with your saw and not damage the teeth on your saw at all. Most of these wedges have teeth on them, and that is desirable because as you force it into the wood, these teeth will engage the wood so that they're not as likely to pop out. A few of them don't have any teeth on them. All of these have a smooth side and a toothed side. They come in a variety of lengths. You want to use the longest length for your big trees. The problem with using a big wedge on a small tree is that you only have so much space for the kerf. You've got your back cut, and as you go through, you're likely to run into the hinge if you overdrive it. You can see that happened here, so that's a good way to damage your wedge. They also come in a variety of flare rates. You can see this has a gradual taper here. This one is more abrupt, and with the small one it is even more of an angle. The smallest one is best for a small diameter tree. The largest is going to be best for a large diameter tree. And if you've got a gradual taper to it, it's easier to drive it into the wedge as the tree is trying to constrict it. In addition to plastic being good for protecting your chainsaw teeth, these are also much lighter than steel, so they're a lot easier to carry out into the woods. Having a variety of sizes is good if you're going to have a variety of tree diameters you're working with. The other big advantage of the plastic is that it can be used in these bright colors so that if you drop them on the forest floor they're easy to find, whereas the steel wedge is either going to be rust colored or something towards black, and that can easily get lost down in the leaves, so the colors are another big plus. Occasionally you'll have a kerf that even though you've opened it up to the full width of the wedge, it's not enough to cause the tree to lean over, and you need to put two wedges on top of each other. That's why one side has the smooth surface and the other has the teeth. If you put the teeth together, you're going to damage the teeth when you drive them in. So teeth only on one side. You want to place your wedges far back from the hinge to maximize the lever arm. Also, using several wedges minimizes the load that each of them has to carry and how hard you have to hammer on them. So it's better for your wedges to use more of them. Wedges are good for other things as well. Now, my saw is not actually stuck, but I did use it to go deep enough so that the top did start to close, because I wanted to demonstrate another basic thing that you can use wedges for. If your saw does get stuck, you can open the kerf up with a wedge. And then it's easy to get your saw out. However, it's actually more interesting than that. If you watch closely, you'll see that as I drive the wedge in, it tries to push the top apart. The bottom is holding it together, and that causes the log to rise, which is kind of amazing considering what a large log this is. If you look closely, you'll see the log coming up. And that can be helpful if you're on rocky ground and you want to get it lifted so that you can put a piece of wood under it, keep it up off the ground. Unfortunately, when you do resort to stacking wedges, they are prone to popping out. The following video is used by permission from Out in the Wood, from his video Hairy Spruce Flying Wedges. While that incident was fairly benign, cross-stacking can be fairly risky. The following video is courtesy of Human from his video Wedge to Knee.
Got it right in the knee. That did not feel good.
Clearly, there is a need for a wedge to replace the need to stack two wedges. I searched the market trying to find a wedge with a sufficient thickness, but I could find none, so I resolved to make one. Unfortunately, I have to work with steel rather than plastic. To make our wedge, we're going to start with this piece of steel, 1 inch by 2 inch and about 18 inches long. It's not the ideal piece of steel, but it has the ideal virtue that it was available. So with this amount of steel, what I'll probably do is cut it in half and make 2 wedges. The one end is about the right width that I want to insert into the kerf that's already been opened by the plastic wedges. So this part up here needs to be made significantly wider. And that's a very difficult thing to do. The process is called upsetting. And what I'll have to do once I've got this cut is I'll have to set it down and hold it and then hit it with a sledgehammer. And I want it to thicken up here, get wider, but I don't want this to get wider. And when I heat it, the problem will be that the heat will tend to travel throughout the thing. The hotter the steel is, the more malleable it will be, and if I can keep this end relatively cool, then that end won't expand when I hit it. Only the hot end will expand. The other problem is with the heat traveling throughout, it's going to be a fairly long piece and it will have a tendency to buckle. And I don't want it bending out one way or the other. So what I'll have to do is do a few good hits on it, and then each time I'll have to adjust to make sure that it's back into a straight section so that I can hit it again, and each time I'll have to recapture that buckle. Being thick, it's slow to heat, but it's also fairly slow to cool, which is definitely to our advantage. So we wait until the last second to put the blade on it, because the blade is going to cool or get heated and get soft the longer it's in contact. So we want that contact to be brief. Now begins the hard part. It's cool at the bottom, hot at the top, but it doesn't want to stay straight up and down. The top has begun to spread. We don't want it to mushroom out. So what I'm going to do now is take it, put the top down on the anvil, and the cold surface of the anvil should prevent the top from really deforming. And then I'll hammer on the warm or on the cold end, and that should get some expansion into the middle. Starting to get it buckling, and that's not good. So we need to take some bend out right here. And we need to flip it because we've got a bend right here. So we need to drive that bend out as well. And that's just about right. So this is the mate to the piece we started out with, and you can see managed to drive it down by continually heating and reheating this end. We were able to drive this end and get that to widen out, unfortunately both directions. So part of what I'm going to have to do now is take this and hit it in this direction to get it to make that bottom even wider, because I want a nice wide wedge there. Ended up having to resort to this 20-pound sledgehammer, getting my son to take turns with me holding and hitting. And this represents about an hour of work. Most of that is spent reheating, but I say that just to make it clear that this is not a route that anyone else should try to take. This is a lot of work. It was constantly bending as we drove on it, so we had to spend a lot of time straightening it out so that we could get it to go straight down. I'm going to do it because I want to end up with a specific shape, but I'm hoping somebody eventually comes up with something commercially that's made in plastic of a similar size. The wedge has gotten a little bit twisted in the process of forging it. So what I'm going to do is lay it down here on the anvil with one corner held up by this plate, the other corner down here, and I'm going to hold this heavy bar on that corner to hold it down, and then I'm going to whack the opposite corner and see if that can take some of that twist out. Odds are something will go flying, but we'll give it a shot. sparing you all of the additional hammering. This is the finished product. Definitely crude, but hopefully it will be effective. It's 2 1/8 inches wide at the top, which makes it about twice as wide as a wedge, so should substitute for 2 plastic wedges. Rounded this edge so that it wouldn't have a corner to catch as it's driven in. Didn't want to bother trying to deal with places where we got the beginnings of a cold shut top and bottom, because we'll rely on these surfaces to provide the spreading of the kerf. Really wanting to have somebody manufacture plastic wedges that have the extra width at the top, because trying to stack wedges is just not a good idea. It's fairly common to take wedges and an axe into the woods. The axe serves the purpose both of a hammer and as an alternate cutting tool in case your saw gets in trouble. Unfortunately, the axe makes a pretty lousy hammer. The pawl has very sharp edges and corners to it, which can easily damage the wedge, and it's also a fairly small surface to try and contact to the wedges, so a mishit is fairly easy to do. As I mentioned earlier, the wedges are made of a brittle plastic. An Austrian forester who posts videos under the name Austria Forst was kind enough to give me permission to reuse video of a mishap he had. In his video, you could see that he did have on his helmet and his face shield. Unfortunately, the broken wedge came in just above the face shield and hit him in the eyebrow line. This is actually fairly scary because it missed his eyes by just a little bit. If you read the instructions on the wedges, they all say, be sure to wear eye protection. His video started me on a hunt to locate a broad-faced axe that would reduce the likelihood of such mishits. The closest thing I could find was a variety of sledges called fence post hammers. Curiously, they seem to be commonly available in England and somewhat less so in Canada, but only available by import to U.S. customers and only with steep shipping costs. Unfortunately, the typical hammer weighs 12 or more pounds, making it too heavy to lug out into the woods. That had a wide-faced hammer on one side and an axe blade on the other. To make our broad-faced hammer, I've selected this piece of 2-inch diameter solid round stock. It's 5 inches long, gives us a starting weight of just over 4.5 pounds, and during the forging process we'll probably lose a little bit of that weight. To hold it, I'm going to be using these tongs, which unfortunately are 1.5-inch diameter, so it's not the ideal fit, but it's close enough so that I should be able to handle it. What we're going to do is we're going to heat this end, and then we're going to use the fullering end of this hammer. And when you hit with a fullering hammer, it makes it fuller. It spreads the face away from the axis of the hammer. So I'll be hitting it, turning it, hitting it again, turning, hitting. So that should spread the face out. And after the heat is just about done, then I'll take and drive the sides in, because I want a controlled mushrooming. I don't want it to open up and split, and by hitting it back in gently it'll kind of seal up the potential for it to crack. Once I've got the face to the full 3.5 inch diameter I'm hoping for, then we'll see about cutting a slit in the side to put a sledgehammer handle in, and we'll probably end up with something close to about 4 pounds as our final hammer weight. Not quite up to a nice yellow heat, but I'm impatient and we'll go ahead. This 8-pound sledgehammer is definitely starting to wear on me. So here's the progress we've made. Started to cut a slit through to put a handle on this. The top is drawn a little bit off center because of the spreading here, but that should straighten out when we get the other side done. The diameter is 1/16 of an inch shy of 3.5 inches, so I'm going to call that good enough. So we'll heat this up and finish driving the hole through, and then once we get that all about the right size, then we'll start spreading this into a little bit of an axe blade. The lump of steel is starting to become a little bit more recognizable. I believe this is 4140, and it is pretty tough to work with this large a piece of steel. It really takes a lot of beating to get it into shape, and it's definitely not into a good shape yet. You can see by looking at it that it's got a lean over to this side. We'll take care of that by drifting in on this side and then beating on the drift, and that will lengthen this side out and push it back so that we can get something that's a little bit closer to vertical. Here's the final product. It's got a 3.5 inch hammer face to make sure you can hit the wedge. On the other side is a axe, and it's obviously a crude job, but I'm not wanting to try and make this into a finished showcase product. It's just trying to get something functional so that I can drive wedges, and if I ever need to use an axe when I'm out there working with a chainsaw, I have an axe available. And again, it would be nice to have this as a commercial product, something where the head weight is in the 4.5 to 5 pound range. Anything heavier than that is going to be hard to carry, but I think this is going to be a good little tool for me. Well, we had some high winds last night. They took down this beech tree, and it's kind of blocking the path, so looks like a good opportunity to test the axe and see if it's going to hold any kind of a cutting edge. It would help if I could learn how to aim it. Now I'll just try some chopping. Okay. Works reasonably well at that too. So now we'll see if we can use our new, I don't know what you call this thing, sort of an axe, sort of a hammer. Success. And looks like I scared away several geese and a great blue heron.